to hear from the team from ASEE. We have Geraldine Gooding and Jennifer Taylor with us, and they're going to talking about infusing engineer teaching resources into the P-12 classroom. So I am going to bring them up on my screen again. Just for everybody in the audience to know is that, we do a lot of problem solving backstage. And when it doesn't quite work the first time, we always can go back to Zoom in other ways the next time. So I'm going to bring up Geraldine and Jennifer right now and allow them to introduce themselves. Okay, just bear with me here. All right, you two are on.
All right. Well, good morning, and thank you for joining in this session. I'm Geraldine Gooding. I'm manager of K-12 activities and manager of diversity, equity, and inclusion initiatives at the American Society for Engineering Education. So a little bit about me. I have a background in applied mathematics and statistics, as well as systems engineering. But for the past 8 years, I've been delving more and doing more work in the education sphere. So I'm also joined by my colleague, Jennifer Taylor, who is at the University of Colorado at Boulder and a member of our pre-college engineering education division, who I will formally introduce at the second part of this session. So let me just go ahead and share my screen and follow along on the presentation. Okay, I hope all of you can see that. Make it a little bit larger. Okay. So in preparation for the next session that Jennifer will be doing, if you would like to follow along with the live demo, please sign up for a free Tinkercad account at www. If you're a teacher and would like to use the resource with your students later, choose Educator when you sign up. And you'll be able to use this as a virtual classroom with your students. So I've heard a lot that engineering can be a challenging topic to cover in the classroom. And we've heard from teachers who don't necessarily have an engineering background that it can be pretty intimidating. So in this session, we just want to talk about some ways to infuse engineering resources in the classroom. And because of the times we're in the home as well, because, parents are coming in as teachers too. So my experience, what I've learned is that making engineering relatable to the student helps. What is a problem that is personal to them? What is something that they would like to solve? Is it something in their community, in their school, at home, or in their family? So make it relatable so it's not just another project that they have to do. And then this way they can really get an understanding of the engineering design process. So I'll touch on a few resources. Just wanted to give you a little bit of background about ASEE in case this is your first time hearing of us. ASEE is, or American Society for Engineering Education, is a member-based organization that advances innovation, excellence, and access at all levels of education, from pre-kindergarten to graduate school and beyond. We have a commission on pre-K-12 engineering education, and their mission is to connect individuals and organizations who are committed to advancing excellence in the area of engineering education. We also have a pre-college engineering education division, whose members consist of pre-K-12 teachers, college faculty, administrators, and other professionals who conduct research on various topics in this space, as well as coordinate a P-12 workshop each year at our annual conference. So one resource that we have at ASEE is Engineering Go For It, or EGFI. And on this website, we provide lessons, classroom activities, details on different types of engineering. We have an associated magazine of the same name filled with engaging features, graphics, and useful information about engineering college and careers. So the magazine aims to get middle and high school students excited about learning and doing engineering. We also have a newsletter providing fresh lesson plans and activities, news, feature articles, and web resources that are delivered every month by email. So it's chock full of information on what's new in P-12 engineering education. You'll also get information on funding sources if you need to fund money for material to your class. So if we were here in person, and I'm really sad that we're not, I would have magazines to give out. I did that last year when we were in Florida. So I'm missing kind of that personal connection, but, we'll still make it work. So a lot of teachers use this magazine as a resource tool to help with just starting the conversation about engineering. So another resource we have is our P-12 teacher and parent group. So this group was created in response to the rapid change that both parents and teachers had to adapt to because of COVID. So in this group, specifically in the first couple of months, we had daily challenges that were posted by our members. And we asked our teachers and parents to share pictures of works in progress or finished products that their students or their children had. So I just have a few pictures here of some of the great work that the students did in their challenges. And what's really great about this group is that engineering professionals and professors are also actively involved and can assist teachers with specific questions they may have in real time. Another resource is the Discovering New series, where ASEE partnered with NBC News Learn and Chevron for a set of videos highlighting diverse men and women in the field of engineering. And each video has an associated lesson plan based on the type of engineer that the subject is. The great thing about each of these resources is that, for the most part, they use materials that you can find readily available in the classroom or at home, or are inexpensive to acquire, or they may use a free online tool. So the site is temporarily down, but you can see a few videos on YouTube. So if you go to the NBC Learn YouTube station, you'll be able to find some of these videos, and hopefully their site will be back up and you'll have access to that resource. So another resource that we have, if you find that you want to do something a little bit more robust and you need some funding, our pre-college engineering education division has teacher grants of $500 to $800 for teachers to implement engineering lessons. So here you'll see that we just finished a round in early July. So the open period will be early July of each year. So if you have some ideas of things you want to do, you think about applying for that next year. And lastly, so once you've gotten these students hooked on engineering, because you've used some of these great resources and some of the other resources that have been shared in this summit, they may choose to apply for an apprenticeship while they're in high school. So ASEE administers the Science and Engineering Apprenticeship Program, which provides high school students the opportunity to participate in research with a Navy lab. We especially encourage students from underrepresented populations to apply. So this is opening up in the beginning of August. So you know some high school students who are interested in doing an internship, and the internship is going to be virtual because in response to COVID. So please check out the website and have your students apply, or your child. So if you're interested in learning more about ASEE, please visit our website, asee.org. You can also reach out to me personally if you would like more information about any of the resources that I've mentioned, or if you would like to sign up for the newsletter. Please reach out to me. But I just wanted to touch on just a few things that are available for free that you can use to broach the topic of engineering in the classroom. So our next segment, I would like to introduce Jennifer Taylor. Jennifer directs pre-college engineering education for the integrated teaching and learning program at the University of Colorado, Boulder College, at the Engineering and Applied Science. Jennifer is also a member of our pre-college engineering education division, and she taught at our ASEE BK summer camp, which was great. The kids had a lot of fun. So I'll let her tell you a little bit more about herself, and she will take you through the demo. Hopefully you've had a chance to sign up for a Tinkercad account. I think I might skip that, but you can go on Tinkercad.com and sign up for a free account. Thank you.
All right. Thank you, Geraldine. Just bear with me here. I am trying to switch the screens. No, we can't hear you, Jennifer. You just have to talk onto that phone. So bear with me here. All right, there we go. We got you back. All right, Jennifer, you want to go ahead and try and talk? All right, we're going to try. Sorry about this. I'm going to pull them back up here. And we'll go over to here, Zoom, share. Test real quick. You want to speak for one moment? All right, I'm going to reclaim host. Jennifer, I'm making you the host now. Okay, Jennifer, go ahead.
She's on mute.
Can she unmute? All right, hold on one second here. All right, bear with us. Geraldine, if you have other information to share, just continue.
Yeah, if you have any questions or if there's some resources that you're interested in.
Oh, hold on. Hold on, everybody. We're going to get there. This has become much more complicated than what we wanted it to be, but just bear with us one moment. Are you there, Jennifer? Okay, so hold on. We're getting her on. All right, Geraldine, I still have you on. We see her. We do not see.
Can we hear her?
I'm calling her back again. Sorry about this. All right. All right, here we go. Hopefully.
Hello.
All right, we got Jennifer, so she's back. Yeah, you shouldn't even be, yes, just mute that, but
okay.
Yeah. You're on.
Okay, fantastic. There's a simple teaching project that gets hands-on into the world of Tinkercad. And everyone should hopefully have a Tinkercad account. If you don't, not a big deal. It's pretty easy to set up.
It does work really well with Google Classroom. So if you're a Google Classroom educator, you can actually have students work on projects simultaneously, be able to see files through Google Classroom. So either just sign up with your own account or join through Gmail. And the basics, what's CAD, and what you need to know about Tinkercad. So CAD stands for Computer-Aided Design, which is software-based. And it helps engineers, scientists, architects, artists use really detailed two-dimensional and 3D models for their designs. So here an example of a 2D side view and a 3D model of the same object. And so with students, we talk about the measuring of 2D, same thing with, finding area. And that also then gets bumped out when you add in the third dimension, which is depth. And here is timing of the spatial visualization piece is a big deal in engineering with the isometric, the 3D view, and then also the orthographic two-dimensional view. And it's a really great way with Tinkercad to try to build a spatial visualization ability in anyone, especially students. So when you're using Tinkercad, you really want to use a mouse. We ran a camp with it, and it does work with some tablets, but a mouse just makes it much more easier. You want to measure in millimeters. That's the default. And you can see the screen here is kind of a thumbnail of my homepage. If you click on that Tinkercad waffle icon, it'll bring you back to your design page in case you get off into a rabbit hole somewhere in Tinkercad. And what Tinkercad does, it's not necessarily a pure CAD drawing program, but it helps you to combine shapes to create new objects. And you want to make sure that all your objects are touching and that they're flat on that blue work plane. And so basically just drag and place, adjust, and combine. You can group and align objects. And when you're in Tinkercad, there's also in the upper right a Learn section. There are 3 parts to Tinkercad. Besides CAD, there's also there's circuits, and then also coding blocks, which help you code to design an object, which is pretty cool. So when you get into the Learn, there's starters, lessons, and projects, which kind of build in complexity. And so we're going to get into Tinkercad, and the first thing you'll do if you're in there is you'll see create a new design on the left-hand sidebar, and we're going to design a keychain, and I'll jump off of my slide deck into Tinkercad and kind of show by doing, and hopefully you can follow along as you see the presentation. Good old Control-Z or the back arrow to get back to where you were, and again, just hit the waffle box if you get lost. So there is on Tinkercad, as I mentioned, projects, and they have this keychain ring letters, which is really a fun, simple way to kind of first dip your toe into Tinkercad. The activity I'm going to be explaining is built off of a Virginia Society of Technology and Education presentation from their Brainstorm 2020 conference, which Megan McCloskey, who's out of District 95 outside Chicago. I watched her presentation after the fact and thought it was really great. It helped me feel like, well, this is something I can bring in, so I'm going to be modeling onto what Megan had presented. At the end, you can also look at Instructables and Thingiverse for other ideas for tinkering with Tinkercad. So I'm just going to minimize this and jump into Tinkercad. And so hopefully you can still see my screen. And this is where my project page is. And as I mentioned, we're going to do 3D design. That's the default that Tinkercad opens in. And then when you want to create a new design, you just simply create a new design. It gives it a funky name once it generates it. And to change that, I'll give you a quick interface as to what's on the screen here. So as you can see here, really interesting name. You just click on it, and we can just rename it to Keychain Project. That's the icon I mentioned about getting back to where you need to get to the homepage. Here is your recent designs. This is the default for the Tinkercad design piece. You can also have students take their ideas and change them into a Minecraft or a Lego design, which is pretty cool. This is then copy, paste. We also have a duplicate, which is really helpful if you're doing multiple objects the same, and then a delete key there. This is up here in the upper right. If you want to select all or show all, you click this button here. You want to group objects. Once they're selected, you select that, and you can ungroup them. You can also align, and you can mirror. We'll also be able to export designs once they're done so they can be 3D printed as STL or OBJ files. This is the work plane that we see here. You can add more of those. You can add details to the rulers and also different shapes, as I mentioned, you'll be bringing in and combining. Over here is the really fun part. This is the home button to give you the home perspective. You can also then zoom in with the plus key or scroll with your mouse and minus. You can go from a perspective to a orthographic view, isometric view, which is what is, I think, the easier one to work in. And then there's this cool cube up here. If you left click, hold with your mouse, you can just tilt anywhere, any perspective. And again, if I hit the home key, I get back to where I want to be. If you right click mouse onto your plane, you can also do the same thing as moving the cube, which takes a little more dexterity, but it's fun to mess around with that. So it's a home key there. So the first thing we're going to do is go ahead and grab a box. Just drag it onto the plane of your workspace, and you notice that different grippers show up. So these white grippers here will increase if you left-click, mouse, and drag 2 dimensions at one time. I don't like it, again, Control-Z or back arrow up here. If you click on the black grippers and pull, they just increase in 1 dimension at a time. And again, back. And if you want to be more precise, you just click in here and then highlight the dimensions that you want. Again, this is in 20 millimeters. So we're going to go ahead and make a keychain. So just go ahead and do it in 30 millimeters by 70. And you should have a rectangle, something like this. You can left click and drag to reposition your object. And the hardest one that took me a while to find was weird with the depth measurement, the height measurement. It's right in the middle. So you click on that, and we said we're going to make it be 5 millimeters. So you should have something like this on your work plane. And again, I want to just check it out, and I'm just going to do a front view to show you that you can see that things can extend below the plane, so we want to make sure that doesn't happen. All right, we're going to go now down to another object and grab an E2. Just click on it, left click, mouse drag. And we want this to be the same dimensions as our keychains. We're going to make this be 30. Oops. By 30. Oops. Up, you can see I click on the arrows. I should have mentioned this really quick. These bottom arrows let you rotate your objects in the same plane, which we don't really need to worry about yet, or you can tilt them. So again, a lot of interface to work with. So I'm just going to go back to my original tube here. And so I want this to be 30 by 30. The default, there's a shape menu. You can just hide that by clicking the upper arrow there. And so let's make this be 30. Oops. By 30. And same height dimension, I'll make it by 5 so that it's in the same plane as our keychain. So you should have some similar object to that. And we're now going to left click and drag it over and kind of overlap it into our keychain. And to make sure that things look aligned, we can go top, and it looks pretty good, but I'm going to show you how to do the align key. So if you just do click and drag, left mouse key, and create a right box around it and let go, you'll see that all the objects are now selected. And we can do an align, which you can see that these marker points, which will show you where you'll align the objects. We really just want to align them in the middle, which it looks pretty darn good. And now I'm going to click off onto the work plane and then drag and highlight again. And now I want to go ahead and group everything. And when I do that, you can see that the colors now changed. That means that everything is now a single object. I'm going to go back to my regular view here. And so now I'm going to show you how to work with holes, which are kind of fun. You can take out negative space. And again, back to your basic shapes on the drop-down menu. There are text and number options. And I'm going to drag in a text box here. And in this one, I'm going to type under the shape menu. Just going to put my name in there, whatever you want. Obviously, you can see this is not going to fit within the keychain design that I have. So I'm going to go ahead and close that out. Back to my grippers and highlight them. I need to make sure that it's less than 30, so I'll just call it 25, so it fits within the width of the keychain. And we'll make sure it's less than that 50. Let's maybe make it 45. So it should fit. And the height, we'll make it down to 5. And so now I have my name. And so now I want to make this be a negative space. I could have taken this and changed it to a hole to start with, but I'm going to show you how to do it. So I select my object here, and I've got this whole option, and now you can see this is like, quote, see-through. So I've created negative space, which I'm now going to drag my name onto a keychain. And again, I can go to the top and align things if I wanted to. And again, left click drag to select everything. And I'm going to go ahead and align it. I want to make sure I align it through the middle. Looks pretty good there. And I'm going to left click mouse drag again, and I'm going to group it. And so now my name has been removed from the keychain. And there you go. I can also do some fancy stuff here, maybe change the color of my keychain. There's multicolors, different options, whatever you want to do. Pretty fun stuff. So this is, again, a very basic, really quick introduction to Tinkercad. I wanted to, say, add objects together and group them. I'll show you really quickly how to do that. Let's say I have a block here, and I want to put a work plane on top of my block. And then that now means the workspace is on top of that block, and I can go put that cube up on there, and I can group them if I wanted to. So it now becomes a single object. Okay. Just going to jump back into presentations for a final wrap-up to leave some questions in case anyone has any at all. And my contact information is down at the bottom there. And we are really excited about trying to collaborate with other organizations to try to get some sort of modules going online. So we'll be posting these on our Integrated Teaching and Learning Program website. So feel free to reach out if this is something that you're interested in connecting on. So thank you.
Thank you. All right, Geraldine and Jennifer, thank you both so much.